Well, hello again. And in this presentation, we're going to be continuing on our theme of understanding herbal basics. And one of the really big issues, I think, that is worth discussing about using medicinal plants to help people with a multitude of health problems is that we are using chemical agents that are complex, that are composed, even in a single herb, that are composed of more than one chemical, unlike a drug, which of course is a single chemical on its own. And of course, when you get to the way that most herbal clinicians practice, they're combining herbs. And so the complexity goes to the next level. So is this an advantage or is it a disadvantage? Why should we use chemically complex products in healthcare? And certainly when I go to a convention, or sometimes I meet some straight scientists at a party, or a social gathering, one of the questions they ask me is, why are you using these chemical soups? Surely there's a drug in there that you can isolate that delivers the activity of the herb. And to them, chemical complexity means uncertainty and too many variables. So as I said, why not just determine and isolate the active component and use that instead? And of course, that's what's been done for many modern drugs that have been developed from plants. But there are two problems here. The first is, if you do isolate a drug from a plant, often what we witness is a huge increase in side effects. And the best example, or a very good example of that, is reserpine, the alkaloid reserpine from Rauwolfia. Now, Rauwolfia is a wonderful herb for high blood pressure. Its use is restricted, unfortunately, in most countries. But one reason why it's restricted is because the isolated drug from it, reserpine, that was one of the first drugs developed for high blood pressure, and I think also for anxiety, caused severe depression. But you don't tend to see that for the whole Rauwolfia extract. So that's the first problem. The second aspect is, for most herbs, we don't know what the active component is. So, a clear example where we do would be the carvalactones in kava. But what about St. John's wort? There's a lot of debate about what is active in St. John's wort. And the reality is probably that the whole herb is the active component, not any isolated phytochemical. There's another interesting theme that is developing in modern medicine, and that is that for various therapeutic problems, various health conditions, often approaches are now being clinically tested where more than one drug is being given. In other words, a multi-agent medicine. So it's interesting that because of the complexities of many modern diseases and the enhanced understanding we have of them, often more than one drug is being used to deal with it. But of course, using a chemically complex approach is nothing new for herbal medicine. The other interesting aspect of a chemically complex product is that a herb can multitask. Even a single herbal extract is a nature-designed multi-agent medicine that can simultaneously target a range of pharmacological effects and indeed a range of health problems. And we take the case of ginkgo biloba. It's been proven in clinical trials to treat a diverse range of health conditions, from dementia to vertigo, to tinnitus, to intermittent claudication, anxiety, and indeed alleviate inflammation, cardiovascular, heart benefits. All of this has been shown from just the one herb. And I believe that's by virtue of the fact that it is a multi-agent medicine. And this also helps explain, as I was noting before, why the active constituent in many herbal extracts has been so difficult to identify. So let's talk more about the elusive active component. As I've said, for most, if not all herbal extracts, the active component is a whole herb itself. No single phytochemical can be shown to be responsible for whatever it is that is being observed as a therapeutic activity. And in fact, many pharmacological studies where they have investigated a herb in this way for a single pharmacological target show that the activity is spread across at least several components. So these key phytochemicals can act in concert together in either a one-dimensional way, which can be either additive or synergistic. And in an additive way, there's a simple addition of effects from the two components. In a synergistic way, one component seems to enhance more than an additive way the activity of the other. So I'm going to elaborate soon on this concept of addition and synergy. But even then, this is only one-dimensional, and there's a multi-dimensional aspect to herbal therapy that I will be discussing in the next presentation. Things like the entourage effect and network pharmacology. But let's just look at this simple one-dimensional concept of synergy. And certainly, just understanding the existence of additive or synergistic effects makes a strong case for using complex extracts, for using a complex therapeutic agent. Now, in the case of synergy, the effect of the combination is greater than would be expected from the arithmetic summation of the components. So an additive effect, the effect that you get is as expected from adding the effects of the components together. In the case of synergy, you add the effects of the components together and it's higher than what you would expect from that addition. So put simply, mathematically, 1 + 1 doesn't equal 2. 1 + 1 = 2 is an additive effect. 1 + 1 being greater than 2 means synergy is at play. So in other words, there's a cooperative or facilitating effect between the components. So how do we determine synergy? Now, some of you might be surprised that this is well defined in pharmacology, and they use a graphical method called the Herbal method for demonstrating synergy. So that's a graph where the dose for a given effect is plotted for various mixtures of the two components that you're looking for a synergistic action between. We're calling them A and B. So you do pure A, pure B on the axis, and then various combinations of A and B. And you're plotting inside the graph, you're plotting whatever effect it is you're measuring. So this is the Herbal method of defining synergy. So you see you've got component A on the vertical axis, component B on the horizontal axis. At the two extremes is pure B or pure A, and then in between you're plotting various mixtures of A and B and the pharmacological effects that you're measuring. So if you're getting an additive effect, that will be that dotted line, that straight dotted line that will show the additive effect. But if you're getting a synergistic effect, you can see that that curve will be concave. It'll loop down. So you need less of A and B to get a given effect because they're enhancing each other synergistically so that you get that concave curve. In contrast, if B or A antagonize each other, then you're going to get that convex curve. So you can see you get addition the straight line, antagonism, the convex line, and synergy, the concave curve. And this is an example for ginkgolide A and B, demonstrating anti-platelet activity. Well, it's more like anti-path activity. And you see the concave nature of the curve. Therefore, there's synergy between the two ginkgolides. And also, that's been shown for the laxative effect of the senosides in senna. And this anti-path effect, as illustrated in figure 2, shown there on the slide. Now, another way you can potentially measure synergy is the comparative method. And here we see this done for THC, tetrahydrocannabinol, from the medicinal plant cannabis, and the whole cannabis extracts. And they're looking at resistance to flexion, so kind of a muscle relaxing effect. So here you can see on this graph that you're getting an effect over time of a single dose of THC, and then that same dose of THC in a cannabis extract, you get a much stronger effect over time, as evidenced by this higher percentage change in muscle resistance. So in other words, there must be other components in the cannabis extract that are facilitating the muscle relaxing effect of the THC. So in this paper by Baker and Williamson, they're proposing that THC having a stronger effect, the same amount of THC having a stronger effect when it's in the context of a cannabis extract versus a pure isolate, is an example of synergy. And that may well be the case, but there could be other more complex explanations involved. And this, of course, has the use of language, the entourage effect. And the entourage effect feeds into the concept of network pharmacology that I'll discuss in part 2. So if we look at why synergy occurs in a pharmacological context, there are two key mechanisms: pharmacodynamic or pharmacokinetic. So in pharmacokinetic synergy, one component of the herb makes the other component more bioavailable. So it doesn't make it more active, not more pharmacodynamic. It just makes more available to the tissues. And this is particularly relevant for herbal products from infusion or decoction, where you get this special third type of synergy, which is enhanced solubility. So you're extracting the herb with water, and a key component is not very water soluble, but you put in another herb that helps that key component solubilize. That is an aspect of synergy, and explains why licorice, for example, is often used in traditional Chinese medicine formulas. Obviously because of the effects of the licorice, but also because the saponins in licorice enhance the water extraction of other key components. Pharmacodynamic synergy is where definitely one component makes the other component more active. And I gave you those examples of ginkgolides and senosides. But there are other examples that have been shown in the literature. And one example is that the antibacterial effect of the whole extract of Hydrastis canadensis is far greater than that you would see from the same concentrations of its individual alkaloids. And the anti-ulcer activity of a fraction of components from ginger was 66 times that calculated from the effects of the same amounts of the individual components of that fraction. So thank you. That concludes part 1 of why use chemically complex mixtures. And in part 2, which will be out in a month or so, I will talk about these concepts of the entourage effect and network pharmacology. And they're very, very sophisticated concepts. Thank you.